Well, good evening, everybody, and thanks for joining us tonight. We appreciate everybody. I know everybody's busy and taking the time to join in and sit in on our little soiree here that we're going to have. In the chat section, you can find a link for the current vehicle checklist, certification checklist. So if you would like to download that or have a look at it so you got something to follow along, we're going to go through the inspection sheet just like we're walking around a truck and
Hello?
inspecting it. So
Hello?
hopefully everybody's got one. Or
Does my
would
mic
like to
work?
get if you want
Anybody
would
hear
like to
me?
get one to follow along.
Hello? Okay, I gotta go volume up.
Are we good?
Yeah, I've got everybody muted except for the staff. We're going to ask that, yeah, as you might want to pull up, if you're not familiar with Zoom, there's a little chat box you can pull down. If you have a question as we're going through, just put Q or put a and I'll unmute you. The guys will let me know you have a question, and when we have a chance, I'll unmute you so that you can ask your question. That way you don't have to type it out. And that way we can move along. So for now, I have everybody muted. So
All right, so we're going to try to go through this, just go through this list like we're starting at the top, and just we picked up our sheet, and we're going to go just look at the truck and go right down the truck. We make the assumption here that you guys that are here, obviously you know what you're doing. You know your way around the truck. You know your way around a 9/16 and a Phillips screwdriver. So you know what you're talking about here. So we don't have to go into the nitty gritty, but we want to kind of go through this, explain the rule, and move on. So we'll just start right at the top. The version 26.0 is our latest. MTRA has had several revisions of these over the years, but this is the latest one. And if you look at this sheet, if you're not familiar with it, it follows along the rule books. The rule number is there for you to reference if you're inspecting a truck and you want a little more detail. You can quickly look it up right in the rule book. So, and the rule book's also available on the website. So you can look there and you can quickly gain access to what the rule is. And always, we also say if you don't understand or you want a little more clarification or you run into a situation that, man, I'm not sure about this, you're welcome to call somebody. We'll gladly take it. You know, any of the board members, you can call us and run it by somebody else and get another opinion. Because Lord knows you're going to run into things, we all do, that we can write these things till we're blue in the face, but we still somebody comes up with a new idea, somebody comes up with a new product or something that's new and we maybe haven't seen yet, and well, geez, what's this? So you know that's available. Just give us a call, anybody a call, and run it by them. We'll try to get you an answer. Another thing is that a lot of the materials or bolt sizes or things like that are specified in here, they're minimums. Maybe somebody says that something's got to be bolted on with a 3/8 bolt or something, and somebody else got a 3/4 inch bolt. Well, that's fine. This is the minimum. So if they had a machine screw or something holding it on instead of a 3/8 bolt, then no, that doesn't meet the rule. But if it's something bigger, you know what we're talking about here. If they got a 1/4 inch of something where an 1/8 inch is specified, well, that's okay. If they got something heavier duty, that's okay. These are minimum standards that we want to see. So with that in mind, we'll start right at the top of the sheet with a rear kill switch at the rearmost part of the vehicle, pull or twist type. You can have the pull ones, you can have the twist, the big twist types. Kill all the battery power, shuts everything off. Easy way to check: turn on something electrical, a fan, or put thing in reverse, a backup alarm or something, and just pop it off. So we want to, obviously we need to kill them, get all the power shut off so that there's a situation, the electrical's shut down. The battery secured, covered with rubber, Lexan or plastic, dry or gel type batteries only. There's one of those twist type switches. Uh, those are legal too, in addition to the pull rings. But the batteries, we want them covered, the terminals covered, the connections on top covered. So if something gets smashed down on top of them, there's not an arc and not a fire. Be aware of things that could collapse in on them, in the event of a wreck. So we want them covered. And they got to be secured. Obviously, you don't need a battery flying around. There has been instances where they've come out, and that creates its own mess. The external crossover relief valve bolted directly to the orbital valve or the remotely mounted ones. There's an example of remote mounted ones. We'll accept either kind. The point is we want to have this it vents the pressure across when there's a spike so that it doesn't rip the steering wheel out of the driver's hands. Broken arms, broken hands, broken wrists, fingers result when you don't have these. So they've saved numerous drivers over the years. They're a little bit that kind that bolts the orbital lights on there. The big square there is that the hoses are coming out of. That's the valve. That's probably the easiest to find. But there are the kind that are in line down they might be mounted on an axle or 4-link bars anywhere. But you can see the hoses go to them, through them, and then down to the cylinders. And that's what we're looking for. The accumulators mounted securely and away from the tires. 5/8 bolts minimum in double shear. So we want the bolt in double shear. Steel or aluminum clamps only, not a rubber clamp. Single bolt clamps at got to be at least 3 inches below the accumulator caps. The cap restrictors are also required on all accumulators. So we want a guard on there to prevent the cap from coming off. We want that clamp down far enough so it doesn't act like a can opener if the tire does hit it or something hits it and it comes up and tries to peel the cap off of the shock. There's been instances of that happening. So make sure that clamp is down far enough on the shock, the one that holds the accumulator to the shock. Some accumulators are bolted directly to the shock. Some have a hose. So you just got to watch where they're at, and like this one, you can see where the tires have rubbed it. That's more common than not. The tires do rub them. The tires deflect. They do hit them. So be aware. You can see that clamp is right up against that cap, and that's what we got to watch for. Sometimes the clamp can try to peel the cap off. So and those guards that we're talking about are very important. Instances of those shock accumulator caps coming off and going through roofs of arenas, going clear over grandstands, going hundreds of yards from the infield of racetracks past into spectator areas. And of course, nobody is expecting that thing to fall from the sky. So, that extremely important that we have those and that they're securely fastened tight. They're on there and they're close down to the accumulator so that the accumulator doesn't have room to accelerate. The cap have room to accelerate when it comes off. It's going to hit that immediately and that's it. It's going to make a hell of a mess, but at least the thing isn't going anywhere. So, that's what we want to see. Fuel tanks and the fuel cell securely mounted, a minimum of 2 1/8-inch by 1 straps, and steel or 1/4-inch aluminum shielding, Lexan shielding below them. So we want to see this. You can see the straps there holding the tank in. That tank's in a metal box. More often, I think you're going to find those plastic jazz type fuel cells, those plastic tanks. There's the vented caps. We don't want that because that's obviously is an opening right to the outside. So we want the tank vented instead with one of those rollover tip-proof valves somewhere else. A valve like this, or maybe it's a valve that's right in the tank. They're underneath the tank. This one's got some aluminum tread plate, something to cover the bottom of the tank so it doesn't get pierced 4-link bar comes off or something, whatever it happens, something flies up from the junk car or anything stabbed the tank. Um, we gotta watch for that. We gotta watch for fittings that can be in areas where they can get torn off, and also look for wheelie bars, things along this line. Somebody does a wheelie contest and makes a big spectacular run and lands and bends the back of the thing up and smashes the fuel tank up. Watch for that, or even lands in the dirt and shoves dirt all up in there and smashes the tank up. Seen instances of that. So have some room. There should be some room around that fuel tank so if stuff comes in on it, but you want the roll bars and all that guarding it. Not just the tank, right out in the end where it's going to be the first thing to hit. Kind of makes common sense. 4-link bars, minimum 2.5 inch lower, 2.25 inch upper, 250 wall DOM with minimum of 1 inch rod ends. Nothing smaller is going to hold up. We've learned over the years. So look for the good 1 inch rod ends. Is typical. Grade 8 bolts in double shear, and two ears where the bolt goes, not just one. That's what we mean by double shear. The bolt goes through two pieces of steel, and it captures that heim joint in the middle. The firewall and the windshield. Now, of course, firewalls, you're talking about the front firewall, you talk about the rear firewall. But windshield, we got to have a windshield. We want an 1/8 inch polycarbonate or Lexan in the windshield, not plexiglass. We want the driver protected from fire or from tire debris. Here's our firewall, the red box there. Motors in the back in this truck. Pretty self-explanatory. If the motor, if something happens, the motor explodes, whatever, want to protect the driver. Parts are going to, come if fuel or oil or hot oil or whatever blows out of there. We're trying to protect the driver. Tire debris protection. In the example of the rear engine truck, here's the tire debris protection in the green square. If the front tires throw stuff back, we obviously don't want rocks or oil or dirt from the track or anything, oil from a broken shock, anything like that that comes flying back. We're trying to keep that from hitting the driver as well. So we want we just don't want the driver sitting there and wide open. Lexan like this that's bent in a sharp 90-degree bend. You got to be very careful about that because it tends to it looks cool, really nice, but it does also tend to break very easily. So be aware of that. Just when you're looking at things, think about if you were standing down there by the tire, look at the driver, and can something go up there and hit him? Could you throw a baseball at him and hit him? That's the kind of thing we're looking for. The tabs that mount the Lexan, which side are they on? Look at that and make sure that the Lexan is, it's good that you can't just push it on through if you were to, take a punch at it or something. Just kind of look at it and see how it's protected. The floor is another area where we're indicated here in the pink square that we're looking at where we got to have good protection. Guys have run over RVs and camping trailers and boats and debris like that, and stuff comes up, comes through the floor, more than you can imagine. Boards, all kinds of stuff has flown up and almost hit drivers. Here's an example of a tread plate floor, very nice, robust floor that's going to protect the driver. Not only that, but obviously all of the stuff turning and burning underneath there. We don't need any of that coming up and hitting anybody either. So the seat, monster truck specific containment seat. We got to have we only allow real monster truck containment seats now, racing seats built specifically for monster truck racing, not a van seat, not a tractor seat. Even the off-road seats of years past are outdated now. This is what you need to protect your driver. And it's got to be bolted in, mounted in correctly to the frame or the outriggers with minimum of 4 3/8-inch grade 8 bolts. So, you know, how it's mounted is important. The greatest seat in the world isn't worth a damn if it's just half-assed in there, and you know, then the guy breaks loose when he crashes, and he's strapped to his seat, but he's still flying around. That's no good. So, make sure that that seat is in there in a good workmanlike manner. These seats are big. They attach, you know, several. In order to be in there properly, they're going to need to be attached at the bottom and the top. They're big and they're bolted in several places. Look at it, make sure you can tell, you know, if it's in there good, and if it's the guy's going to stay in it. You know, you got a 100-pound driver or 300-pound driver. You got a lot of variation in our sport. Guy's going to be strapped into this thing, so make sure that it's mounted pretty good. Nobody can control anything if they're not behind the wheel.
We're moving along pretty quickly here, so I want to remind anybody, if they have any questions as we're going through here, just let us know, pop something in the little chat or something so that we can respond to anything you might have.
Yeah, there's no dumb question. If you don't understand, or if why is that, or why not like this, just let us know, because there like I say, there is no dumb question. All right, where are we at here? Chassis built prior to 2017. We allow the 8.1 piece roll cage, 2-inch diameter DOM tubing with an X brace. So the older stuff that's still out there, obviously, the modern day monster truck chassis is way more sophisticated than one from 10 years ago. But in an effort to not just instantly relegate a bunch of vehicles out of service, we thought, well, let's still allow certain ones grandfathered in, so to speak, and then as they get replaced with more modern equipment, then they'll get updated. So the cage and chassis rules kind of go along with the age of the chassis. The newer stuff, much more sophisticated, more bars, different materials. You know, more steel and heavier duty stuff.
Back in the 90s and before, when we were racing, we were trying to build the trucks as light as possible. So, you know, there was very efficient use of tubing. Nowadays, everything is a lot more, a lot bigger ramps, bigger jumps and stuff. So the tubing had to be beefed up. Wall thicknesses were beefed up. More points of contact on the chassis to keep from bending the main frame rails and stuff. So they've evolved quite a bit.
And there's some really good diagrams in the rule book that don't be afraid to reference them, and some really nice stuff that helps explain some of these things and what you should be looking for and some of the additional bars.
One really important point is we see where the outriggers are down there at the bottom. You want to make sure that those outriggers are supported below, that they're not just hanging off the end, because they will fail in a crash.
Yeah, that's a good point, and you can see some of the triangulation and support is extremely important of those. Those bars behind it, yeah, this example here, those bars behind the seat, again, those containment seats often attach in this zone here, up there by that U, so to speak, right behind the driver's head. So seat belts are going to fasten there, the seat's going to fasten there. Obviously that takes a big load on it. Somebody does a failed attempt at a backflip or something, and the truck lands directly upside down on its cab, all that load comes down there, pushing on all that stuff, and the seats mounted there, and so when it all bends together, and that can cause some problems. So that's why this is being reinforced so rigidly with the new trucks.
Yeah, the idea is that if the cage collapses, it takes the seat down with it, rather than the seat staying in place and the cage coming down and potentially getting into the top of the driver's head or something.
And then as we get into the more modern truck, a 12-point cage.
You have those additional corner supports. You have the suggested secondary inner cage. In some cases, it's an outer cage, but it's a secondary vertical behind the driver.
And we boost up to 188 wall in some areas.
A lot of this tubing thickness stuff, the forelinks and the cage, those are driver write-offs. The drivers have to. There's a section where they check off that they are verifying that the tubing is the required thickness, since there's really no way for you to test it short of drilling a hole in it. So, but it's for your own protection, so that you know that they vowed that it is the proper thickness. Lots of additional bracing, lots of triangulation. You see how those support tubes under the outriggers keep the triangulation, because a lot of the early trucks, stage 3, those prior to 2017 trucks, didn't. A lot of those, the trucks were lighter, and again, we weren't doing as much with them, so they could get away a little bit without having the supports under the outriggers like that. But these newer, heavier trucks, and those outriggers will fail, because you take a hit on the corner, it'll push that down. So it's important that force is carried all the way through, where you have this continual load being transferred from one tube to another. You don't want dead ends. You don't want a tubing ending in the middle of another tube, because it'll punch right through it. And this is getting into the weeds a little bit on design, but you want to be conscious of watching a lot of the way some of the trucks are building their upper halos. There's different. Let me get you a picture where you can see it. Okay, you see that what would be like the A-pillar tube in this case curves and bends up and connects to the main cage, or a main down hoop. Some guys will do a halo tube with a separate piece attached there. You got to be careful on how that's done, because keep in mind that a tube on end is effectively like a punch. So a really hard hit will actually, that sharp end of the tube will punch right through another tube. That's why you don't like having T's like that. We like meeting things in corners where there's more surface area, or that there's additional gusseting to keep those things from failing. If you notice, virtually every tube you see has something behind it. It's very rarely will you ever see a tube that just ends at one point that's not carried through. This one's an example of that secondary vertical cage, which there are a few things that we have included in here, because some promoters will have a slight variation or a higher standard in terms of cage requirements. So we have those additional things in here just in case, and they're things that over time we will adopt as being required. At this point, the MTRA does not require the secondary vertical hoop, but it is highly recommended. And that's what you're seeing in this case. You're seeing that outboard to the back of the main driver compartment there. Here you're seeing where those points where it's important that you have a lot of conjunction of tubing. So that's why we want that heavier wall tube there on the frame rails, because the last thing you want to see, and this is getting into more of a driver or owner situation, but you don't want those tubes crushing. So we require heavier tubes in certain areas. So these are things you're going to need the driver or owner to sign off on.
And there were some examples of some chassis that were built that failed exactly in those red spots there, that failed miserably, and I mean, essentially the truck was totaled. because like Marty said, there's so many things coming together right there. The modern day chassis is a work of art. There's so much stuff going on, and the loads and stuff that get transferred around. It's amazing. And in reference to the 9,000 pound minimum weights and stuff back, the truck it used to be there were some even lighter than that out there, and now everybody's gone the other way. Now trucks are 11,000 pounds again, and as a result of that, we hold up better, but they also, there's more mass, more weight, and we're dealing with it. So more bars,
That's a
heavier
really
bars.
critical bar right there. That angled bar going up to the cab corner where the A pillar meets the roof. That secondary bar right there was something that got added within the last few years. It's really important because we have seen, you're visualizing this thing. You've got this triangulation, and you're looking for these triangles, but you're looking at it, longitudinally. If you view that like from the front, you'll see that corner without that support is not triangulated laterally. So it needed another point, because the impacts are usually diagonal, or they come in different directions. They're not always straight from the top. So that extra support tube goes a long way to strengthening. And we've, and if those of you that have attended our normal tech schools, you've seen video where we've had in-cab footage where you can actually see the flex of the cage as it hits the ground, where, in a case where it didn't have that support tube. And there have been serious injuries that have been sustained as a result of a failure of that front part of the cage. This is, this stuff we're hammering on it quite a bit, but it's because, this is a really critical point, and we want to make sure that all your drivers are very safe, since, of all the safety equipment we have, the seat belts and the roll cages are probably the things that take, the most abuse. It seems like those things are put to the test very, very often.
All right, so we're going to look at 6-point roll cage on some of the old steel bodied stuff. Not allowed for racing.
Yeah, these are more for like nostalgia type events, car crushes, or those kind of thing. Nothing that gets. I believe we have in the rule book, it states that these trucks must keep at least 2 tires on the ground at all times. In other words, anything that gets all 4 tires in the air is deemed a race truck and would not fall under this 6-point rule.
The sidebars. Here mostly to protect in case another truck gets into 2 trucks run into each other. Let's say the shutdown area or whatever, somewhere on the race course, 2 of them get together. We're trying to keep the driver protected from another truck entering the cab. So, some guys get pretty creative here. You got a driver that climbs in and out of the driver's door, so they have to have a different kind of bar arrangement. This is, pretty common of a modern day truck today. This is what you're going to see. Now, there may be some bars that have to be removed. Like this is a way that a coupler is put in there so that a bar can be removed to get the seat in and out, because those big seats, you can't get them in and out of some of the trucks with all the cage bars in place. So there are some specially made couplers like this that come apart so that you can take a bar out wherever you need to get the seat in and out. So that's perfectly allowed as long as it's done correctly. You can look at it and see. When one of the things that when you're inspecting a truck and you're looking at these cages, look at the welds. What you got to be you got to be looking for workmanship. It's very important, not the welds that aren't done correctly, destined to fail. Not only whether the material's right or not, but if the weld's not correct, it doesn't even matter. So got to have the right welds. So be looking for that. Look for those couplers if there's a way. As you can see in this one, it'll be pretty tough to get the seat in and out. It probably comes in from the top or something. But it when those are important
I'm going to
considerations.
mention something else that is not stated. There are, we, I guess we should emphasize that as tech inspectors, um, you have the ability to make a determination on the spot if you see something that you deem to be unsafe, even if it's not stated. I I very often use this term, and it's not a very popular term with people, but a lot of times I will say this isn't a democracy, or when you as a tech inspector say no, that's not sufficient, it's not up for vote. It's not, or the owner can't argue his way into overriding your decision. Ultimately, you are the one that signs off on whether that truck is safe or not. And related to that, something, because this popped into my head because Tim referencing the removable uh, cage couplers and all. There are instances out there of trucks that are so tight, they're designed in such a way that the driver cannot get in and out wearing his Hans device, his head and neck restraint system. You'll see some drivers have to get in the truck to put on their stuff. That's, for me, was an automatic fail. Just imagine a truck that's upside down and catches fire, and the driver has to take his gear off to be able to get out. No, in other words, the last thing you want to do is as a safety person, or safety response person, is having an inability to get a driver out of a bad situation. They need to be able to get in and out of their truck in full dress, helmet, restraints, everything. And they need to be able to do that quickly. We even have had expressed concerns about trucks that have only one area of ingress egress, because again, like some trucks, they're designed in such a way that the driver can't get out through the side or through the windshield. They can only go out through the bottom. Well, very often that's the fire source. In other words, the fire source is more often than not the transmission. So a lot of times the fire is coming from below. They need to escape through the top somewhere. So that's, these are things that are not so much written in stone, because it's very hard to word, to develop rules that cover every conceivable scenarios, because then they become almost overbearing in normal situations. So this is where that you as tech inspectors, we kind of leave this to your discretion and how you are going to deem whether that is a safe condition or not a safe condition. And if it's something that you feel is beyond your level of expertise to be able to make that determination, as Tim said, we are always available. Very often we get texts in the middle of the night, hey, look at this, does this look okay to you? Do not hesitate to message us at any point, call us, wherever. We're always available for that.
Good points. The split ring wheels, we're not talking about a two-piece wheel, like is the really common. We're talking about this, an old agricultural big A wheel or something from a big wheels truck. Most of them have been weeded out nowadays, but there's an O-ring in that split rim, and we used to allow this. We'd allow them to be bolted so the ring couldn't blow off, or we made them mount the other way so that the ring was inside, but not allowed anymore. So if you see that, those wheels cannot be used. The wheel restraint system. We required the disc now captured. The cable thing was that was a fix along the way that we tried, and it worked for a while until we came up with something better. But this is what's required now. This is a disc that rotates within two plates that capture it, and it's been tested several times, and mostly done pretty well. Unfortunately, there's still wheels that fail or something that breaks, and it's either inboard or outboard of the restraint system. But broken spindles, a common broken spindle or something along those lines, the real restraint will grab it and do its job. And we've had situations where trucks were able to safely drive off the floor or back to the pits, even with a broken spindle, with this kind of system. So it
You'll
works
want,
very well.
you'll want to pay attention. There are many variations on this. Some of them will have double plates on the knuckle side that capture a rotor on the hub. And then there are others that have double plates on the hub and a single plate on the knuckle. And either one is acceptable. There are situations where some trucks will have a single outer plate capturing the ring, which in theory would hold the wheel from separating, although it does allow it to tip further, which increases the chances of it ripping the restraint off. So this is at I would say the promoter's discretion of how much they want to enforce or how far they want to push this rule. But this is a big area. The wheel and tire, we're going to get into it more at the end of this, into more detail about the wheel and tire combination, wheel, knuckle, flange, spindle, champagne, all those areas that seem to be more often than not the weak link right now. We over the the past 30, 40 years, trucks keep getting better. We're improving in some areas. And what we do is we end up moving the fuse downstream. In other words, we'll strengthen the axle housings and now the knuckles fail, or we strengthen the knuckle and now the champagne fails. And so we're always chasing this, but we're getting better. The truck's capabilities are far beyond anything that we could have imagined even 10 years ago. So it's important that we recognize where the current weak link is. And right now, the current weak link seems to be in that interface right there between the wheel and the truck, keeping those wheels attached. We see almost on a weekly basis situations where wheels escape. And the last thing we want to see is somebody get hit by a wheel somewhere along the way. This is another variation. Certain axle types do not lend themselves to a full capture ring. So we allow in those kitchens, this is usually like a ZF or a Dana Spicer or something, where they're a small, compact planetary, very space efficient. So they don't lend themselves very much to this type of normal wheel restraint. So we allow, they're almost like calipers, capture plates, top and bottom. But having said that, we learned that it is critical that those upper and lower capture plates be tied together. See the red plates here are capturing that disc, but the problem is that when they're independent like that, all the load is taken by one or the other at any given point, because sometimes wheels break going down rather than up. So it just depends on the situation. So it's very important that those things be tied together, as you see here. In other words, they're still individual plate capture points, but they have a strap tying them together so that they're moving in unison. This is an example of that would not be acceptable. Obviously, those little tabs are not going to hold that on. So, and that brings up another point. We have this very recurring theme that we discuss at virtually every tech school that we do about spirit of the rule. You'll hear us say that very often. And what we mean by that is, what was the intent of the rule that we developed? In other words, what we've run into on more than one occasion is a situation where a truck builder or a driver or a team owner will have every item that's stated in the rule, but it's configured in such a way that it does not actually accomplish what the spirit of the rule was, and what was the intent. If the intent of the wheel restraint system is to keep the wheel attached to the truck, and you look at something like this and you go, those little tiny tabs are not going to hold that on, obviously. So in other words, it doesn't matter that it has the right size bolts and the right size plate, knowing it was not configured in a way that was consistent with the spirit of the rule. So that's a fail. This is an execution adapting the typical rotor system to a ZF axle in this case. When you're doing this, is something that's not a rule, but it is something that as a tech inspector you have to be very careful of. We will very often see in intros or at the beginning of the show, or as trucks go out and do their, small pop and drops and stuff, that you'll have catastrophic failures that were actually the result of damage that was incurred at the prior show. So when you're doing your tech inspection, it's very important that you look, when you're looking for these wheel restraint systems, be sure to inspect the champagnes, right? Look for cracks. Sometimes the drivers aren't aware that that they have damage. So it's, so one of those things you just got to poke around here when you're in there with your flashlight, looking, checking everything. Make sure that you don't see any cracks anywhere that are something that's just gonna fail in the middle of a show. You'd rather catch it beforehand.
Chris has a question.
Yeah. Yes. Let me back up in the pictures here. See, in a ZF style, where again, there's not a lot of room to be able to do a full, you can, but it's pretty space efficient and very constrained. So we allow them to be separate pieces like this, but you need to have a strap that ties, even if it's just one vertical piece on each side of the bracket, that just ties the upper and lower together. As you see in this picture, you see that one, there's a bolt top and bottom, and that is just tying the upper and lower brackets together so that they move in unison. And obviously this is done front and back. So it allows, it's a little more space efficient than the big elaborate setups. The reason that you can get away with this on the ZF is the knuckles are nowhere near as heavy, or should I say the hubs and all are not nearly as heavy as a Clark or Pettibone or anything like that. So they can get away with a little bit. Now, of course, the wheels and tires and everything are still heavy, but those don't have to be quite as heavy duty as what you see often in the Clark world, where Clark being the ones that fail most often.
All right, we'll move on to the engine. I'll run through the engine stuff and then I'll hand off here. The engine, the exhaust, discharge vertical or rearwards at a 45-degree down angle, up or down, slightly back. A lot of trucks now got mufflers and the headers going down. We just want to make sure that if something comes out of valve, head gasket, something like that, that it doesn't shoot up towards the stands. Guys with I've seen these kind of headers are increasingly popular, and sometimes they'll turn that little exhaust tip down there, turn it away so that it's not blowing down so bad, but they end up turning them right towards the crowd, and that's not acceptable. We got to watch that. You blow parts out of that and right in the stands, so, and they're hot, so an obvious problem. The carb return springs or injection return springs, dual return to idle springs in separate locations. Not if they've got two springs on one, that's fine, but still got to have one on the other side. Some people they'll have 4 or 5 springs on these setups. There's one on the gas pedal. There's one on each side of the injector hat. All those are separate. All those are perfectly fine, but at least one on each side of the injector hat. And we got to be aware of, watch the bolts, the way the screws go in there on those black arms. In this case, that screw, if there wasn't a nut on it, can back out and get against the injector hat. And we've had instances where, because that injector hat's rounded, it gets out there against it. Driver's foot goes to the floor. It goes down and drags past because there's a lot of force on it. Goes down past the injector hat, but it won't come back up, and it sticks. And somebody runs into the fence or whatever. Um, and when you look at it, that's the way Enderley puts them together, or used to put them together. And so it's extremely common, more common than you think, to see that screw in there without a nut on it. They just screw into that threaded black arm, and it'll back out, and it'll bite you when it gets into that injector hat. Best to put a screw or nut on it like this one has, to make sure that it's essentially double nutted, because there's threads in that black arm, and then the nut is on the end so it can't back out, or put the bolt in the other way with a nut on it.
Yeah, for
But
some reason, Enderley ships those things with that screw threaded into the black aluminum piece there, and they apparently don't use Loctite because it's screwing into aluminum, so they have a tendency to vibrate loose. That's why we recommend putting a longer screw that you can put a nut on the backside.
yeah,
So,
but watch for that, because
another
it's
area
tricky.
that it's not a rule, but it's one of those things that we feel is pretty important that needs to be watched. Sometimes, and again, you see how the shaft is threaded. So on some trucks, it's actually closer against the aluminum hat than what you see there.
The throttle linkage, here you got the push-pull cable, um, gas pedal, a real common gas pedal. This is a really common one that a lot of people use. There's that's probably the most common. And this is a push-pull cable, which means it operates in both directions. So if a driver, imagine that you just had a piece of rope tied to the throttle cable and you pulled on it. Well, that works good to open the throttle, but you can't push it back. So we want a push-pull cable, so that if something did go wrong and it's stuck, that the driver can pull the gas pedal up with his foot, and the toe strap that's required, and pull the accelerator pedal back up. So that's why we got a push-pull cable.
Yeah, even if you have a nostalgia truck or anything that's a steel body truck or anything, we do not allow the cable type throttles, because the cabs, a lot of times they'll have a body lift on them or something, and the cabs will shift, and that will pull the throttle. So they need to be a positive push pull.
The blower, you can have an 871. There are several different variations of 871s that have been developed over the years. There's some that look massive, look much bigger, but a 16-inch rotor is what determines an 871. There's all kinds of different openings in the top and the bottom. The rotor angle has to be the standard GM rotor angle as it's designed, not high helix. The high helix ones have a little bit additional twist to them, which allows to put out more air. So we don't allow that. Standard 871. 10% overdrive. It's all we allow. It's changed. That's how you detect the overdrive, is by the pulleys. Count the teeth and do the math. There's a chart in the back of the rule book that can help you. You count the top number of teeth and the bottom number of teeth. The top pulley usually is going to be smaller, because the blower is turning up to 10% faster than what the engine is. So that pulley can be 10% smaller, up to 10% smaller than the bottom one. So count the teeth is the way you do that. Here we have a blower restraint. Holding, this is on top of the blower, but underneath the injector hat. If the blower were to break off, something backfires, the engine backfires, something explodes inside there, this restraint's going to hold the whole mess from blowing up into the air. It's going to have a little bit of play in it, those straps, those seatbelt like straps, to allow it to blow up a little bit, but it can't go very far. That'll hold the whole thing down to the engine. Pay attention to those straps. They do get burned. They do wear. You can see these have SFI tags. We don't have an SFI time requirement on blower restraints, I don't believe, but you can look at them and see if they're in reasonable condition to hold. Fortunately, in our world, blowers don't blow off like they do in top fuel, where it's somewhat regular. In our case, it doesn't happen very often, but when it does, it has and it will, and when it does, we're protected. These blower restraint straps in this picture have silver sleeves on them. Quite common, fire resistant sleeves, quite common in drag racing, not so common in monster trucks. You'll see them because people buy them, and so you might want to slide them out of the way to get a look at the straps underneath. Here we've got aluminum studs, very important, that bolt the blower down to the manifold. Check it with a magnet. We don't want bolts. If there is a backfire, that's the weak link. That's the pop off valve, if you will. It'll pop the manifold, or the blower off the manifold, break those studs, but at least it doesn't destroy everything. It doesn't hurt the blower case, doesn't hurt the manifold, doesn't create shrapnel. It just pops loose, vents out, the restraints hold it, and that's the end of it.
And we don't have a date, but we do have the 14.1 specifications. Like you want to make
Right.
sure that they are, current
SFI approved.
SFI, approved straps.
And you can see here we've got a blower belt guard that's guarding those fuel lines that are going into the injector there. If the belt would come off, we don't want it to take those lines with it and rip the lines off and spray fuel all over the place. We don't need that. So that guard's on there to help that. Deflection shields on both sides of the engine. We're covering from the bottom of the head to the crank, where the crank is so from the head to the pan, in case the rods blow out of it, in case something comes through the side of the motor, we want to protect, deflect it down so it can't get out and go into the stands. Some will be affixed right directly to the engine block, like in this case, where they're right on the engine. More commonly, I think you'll see them attached to the chassis. There's minimum specs that they got to be made from. We don't allow the count the chassis as part of it, so it can be bolted to the chassis, but you can't say, well, there's bars there. That's my shield. No, we got to have the shield on there so that if something comes out, pieces of the block, rod, everything in the engine wants out. That's what Tim Wilkerson told me. So when it comes loose, something goes wrong, and it will, then hits the shield and goes down to the ground. Electric fans pretty much speaks for themselves. We don't want any kind of engine-driven fans. That's just too dangerous. This electric fan, it's all shielded, shrouded. It not only does a much better job and can run when the truck's not running to help cool things, but we don't have a blade flying around and all the problems that can cause. And we don't want cast iron pulleys. In the old days, the old power steering pumps from a dump truck or something that somebody was using worked fine, but it had a big old cast iron pulley on there, and it's not made to spin 8,500 RPM. So we want to see billet pulleys or aluminum racing pulleys, something that's made to withstand the RPM the engine's going to see. And harmonic balancers. The regular stock two-piece harmonic balancers that you'd see on a passenger car engine are not allowed. SFI approved balancers are allowed. Most guys are going to have most places you're going to see a crank hub, degree wheel with a blower pulley bolted to it, and that's all there's going to be. The engine's balanced and doesn't require the balancer, but some people do use an SFI approved balancer down there to help get rid of some vibration, and those are easily identifiable as SFI approved balancers versus the old stock rubber thing that you'd find on a 460 or a 454 Chevrolet or something that's just two pieces that will fly apart. All right, let's go into the transmission and clutch. Somebody tired of hearing me want to take over?
All right. I'm juggling over here.
Denver, take over.
I don't have the sheet. It's not coming up on my link. So
Oh, all
I
right.
was gonna
Well,
throw that
I'll
in
keep
there.
going while you're looking for it. The transmission and clutch. Most of modern day monster trucks now are running the Power Glide type transmission with a reed or dead and bare case that has a blanket inside it. But there are still some other ones. This is the one where the blanket's inside, and this is what you'll most, or the shielding, I should say, is inside, and that you'll run across most often. There are some that have detachable bell housings, so that they, like in this case, so that it could be bolted to a Ford or a Chrysler engine, and that's perfectly fine. Those are all SFI approved racing cases without a blanket. They don't require a blanket. They got an SFI tag when they come new, but oftentimes that falls off. So but you can see these types of transmission cases, and they don't require a blanket. If you're running one of the older C6 or Turbo 400s or 727s or something along those lines, Lancos, then they are required to have a blanket. And the blanket has to be the big blanket, not just the tiny one, but the big blanket with those arrows that have the straps bolted to the top of the bell housing to help hold it in place so it doesn't just slide back. That's the kind of blanket that we require if you're going to be running a blanket. So if you're looking, if you run across a transmission with a blanket on it, make sure it's the right kind of blanket, and make sure it's not all burned up or otherwise compromised, that it's not going to do its job. Obviously, the transmission's right underneath the driver's seat, and you don't need to explain the problems that can cause if something goes wrong. And there's been explosions where transmissions have turned clear upside down, blown clear off of the motor. Just all kinds of massive failures, oftentimes resulting in fires. So no place to to scramp here. We got to look and make sure that the transmission has all the safety equipment in place. The flex plate. In our normal presentation, there's some horrifying video that we have of one of these coming apart, and it killed a guy. I mean, just in an instant. Very important. Obviously with the loads that the trucks see and the transmissions see, everything, we want a stock flex plate that they put to hold a passenger car engine to a transmission doesn't work. So a good racing quality SFI approved flex plate with the gear properly mounted to the flex plate. The flex plate made of sufficient material that it bolts to the crank correctly. You can see in this case the SFI tag right on there. No question that this is a high quality piece. Underneath the transmission, we want to see that that in this case it's green with the bolts sticking through it, that continuation of the flex plate shield on the bottom. The GM style transmission, like I say, the most common thing that everybody's running, whether it's a Ford engine or a Chrysler engine or whatever, Chevrolet engine, they're running them. We want to close in that flex plate on the bottom. So the transmission itself does not do that. You got to have an additional shield there. Keep in mind, the monster truck gets upside down, and now this is exposed. And if that comes apart, and if you happen to have seen that video, you know what I'm talking about when that comes out and it goes through tires, goes through walls, certainly goes through a human body. It's a saw. It's a horrible, horrifying thing that we've seen. So best to have one that doesn't fly apart in the first place, and then have the shielding that, just in case it did, makes it a non-issue. There's a few Lenco things that we kind of skipped over here. I don't know that there's any Lencos still out there. There might be a couple in diesel trucks, but there's not very many that are out there. But nevertheless, if someone is running a clutch, centrifugal clutch, like a Crower Glide or some kind of a clutch like that, we do have rules for the explosion-proof bell housings and all the specs that apply to those Lenco transmissions, B&J transmissions. They have to have blankets on them, and all that's in the rule book to explain that. But quite frankly, I don't know that you're going to run across many of those, unless maybe Hardcore Racing Series comes back out. There might be some guys use them again. The driveline and brakes, drive shafts with billet end yokes. You know, here's some yokes that go onto the transfer case or onto the axle, as the case may be. These are billet pieces. There's one in the center of that brake rotor. Here's a companion flange that's a billet piece. Drive shaft failures, you know, in the monster trucks, obviously the drive shaft speeds are extreme. The low gears and the high speeds, the drive shafts are really whirling. So we've got to have the correct loops to contain them, and those yokes on the end being billet just help things. The loops, when you drive shaft loops have been through so many iterations over the years, but once we come upon this design, it's become a non-issue. These things, they're almost indestructible. They do occasionally take a blow and they'll get bent or something like that, but they work so well that this is just this is it. This is the deal, and it's not up for discussion. You get these, they don't crack. They don't require all kinds of maintenance and stuff. They require at least one end to rotate. We've got these different uh, pins on the ends that hold the heim joints. All this is clearly specified in the rules. They're very, very specific about what we allow. We've had all kinds of welding experts. We had the Army welding experts test these things, and we got all kinds of feedback when there was some drive shaft loops that came apart and caused a fatality. So this is what you see here in orange, and this is what we require.
You want to familiarize yourself with the specs, the distances. Another very critical thing to watch for is the location of the smaller diameter piece that's on the stub shaft. You want to make sure that it's in the right spot, that it's capturing that stub, because more often than not, that stub where the drive shaft narrows down with the slip that goes into the slip joint, that's usually the failure point. When the drive shaft gets out of balance for whatever reason, something hits it, or U-joint fails and it gets into an oscillation, that point is usually the piece that breaks. And the stub itself is a smaller piece that can escape if you don't have that smaller diameter tube in the right spot. So it's very critical. The placement and the distancing between those loops is critical. So, you know, a lot of guys are buying them. Most of the trucks nowadays, you're seeing them, they're buying them from Patrick or something, and they're pretty standardized. But if you're seeing something that doesn't look like it's a conventional loop setup, you definitely want to check the specifications, make sure everything is up to our standard.
Yeah, it's really important, because that's probably one of the most failure prone areas on a truck. The U-joint shields.
That brings up one other thing, just very quickly. And I know that we've discussed this, a return to competition inspection sheet also that we'll be putting on our website here soon, and we'll get it out to everybody. One thing that we see way too often is a truck will break a third member or something early in the show, and or break a drive shaft, and they pull, they're thrashing to get the truck back for freestyle or whatever. We've seen many instances where trucks will be put back together and leave the loops off. or leave a portion of the loops off or something. That's a no-go. Truck should never run without a loop, without a full set of loops on it under any circumstances. I would rather have a truck miss a show than have it go out without loops. It's too critical of a component to allow a truck to run unless it's 100%. Okay. End of rant.
Yeah, good point. And that U-joint shield there, you know, if the what we're looking for is if the U-joint fails, that the caps and the needle bearings and all that can't fly out. You can see here that the end of that drive shaft is pretty well contained. The U-joint, if it did fail, imagine that U-joint failing, the caps can't get out of there. That's what we want. That's what we're looking for. Good examples here.
Yeah, those things will almost always split so that they can be serviced to get the third members in and out.
Those new drive shaft loops, as good as they are, require a rotator, some kind of a rotator. They have to be able, they're so rigid that they have to be able to articulate with the suspension. So that's what we call a rotator device, some way to allow them to move. And there are several different ways that allow that, and we allow it. But you want to make sure that if the guy has that, that it does rotate, so that I guess I'm not being very clear, but so that it can move left and right if we're looking at it clockwise and counterclockwise.
Right. What that's allowing to do is that since the axles can articulate, you know, like this, and the one end of the loop is affixed to the chassis, that's, you know, solid. It depends on what end. There's a rotator can be, by our rules, can be on either end. But what that allows it to do is that the axle can articulate, can pivot from side to side without trying to twist the loops. It allows the loops to twist with the axle or stay parallel to the chassis and allow the axle to twist without twisting the loops.
And it makes a huge difference.
Yeah, if not, every time you're moving around, even just driving around the pits, any little thing, anytime the axle's rocking, it's working on those welds if you don't have a rotor. So in other words, over time, those things, back in the day when we had, flat stock for loops and all, they were elastic enough. They had that they could flex, but these are so rigid. They're so overbuilt that they don't allow for that. They'll break, or something's going to break if you try to articulate them and they're solid mounted.
The jack shaft and couplers, the jack shaft being the shaft between the transmission and the transfer case. Some trucks will have a little drive shaft there. Just like an old F-250 had a divorced transfer case in it and had a little drive shaft going between them. And we want that completely shielded. In most cases, the modern day monster trucks today, that's a coupler there. It's not a drive shaft. It's just a connector, like a rear engine dragster has or something to connect in the transmission to the rear end. But in our case, it's a transmission to the transfer case. We want it completely shielded. Obviously, it's most of the time it's right below the floor. And again, if that gets away, it comes up through the floor and can hit the driver. Or it can go sideways and go out through the side and hit the crowd. So we want that shielded. So if it did come apart, nothing happens other than the guy just can't make the run. So very important. Intermediate shafts. What we're talking about there is a shaft that runs, let's say, from a transfer case in a rear engine truck towards the rear axle, and then there's a carrier bearing and then the rear drive shaft. That shaft needs to be fully contained as well. In this case, it slides inside that tube that you see covered by the cardboard box there. It's going to slide into that tube and go back and make it up with the transfer case, and then the carrier bearing would be right there. So in this case, we're looking down. We can see the tube that shield or that shaft is going to slide into.
Some trucks, some older trucks might have an actual carrier shaft, which is a portion of a drive shaft that will have a U-joint at the transfer case end, and then it goes to the carrier bearing. Those will have like a rubber, sometimes they'll have a rubber, like a horseshoe with a rubber isolator in there. But most modern trucks now will run a spline shaft. It's almost like an axle shaft that uses a coupler at the transfer case, and then it goes to a solid billet block with a bearing, and then it just has a yoke there. So they're simplified. There's less pieces. Those are favorable, but you may see cases where older trucks, Gen 3 trucks might have an actual jack shaft.
Kind of like a long wheelbase straight truck or something that
Yeah,
has several.
Yeah, because there's,
Right.
you can only make those spline shafts so long. In some cases, a real long wheelbase truck might have a actual jack shaft.
The slip yokes, the minimum penetration is what we're looking at here. Where it's a drive shaft that's essentially too short. And this truck cycles its suspension and then the thing comes unplugged. That's what we're looking at. Just when you have a look at it and make sure that it's that it's engaged correctly. There are a couple of different types of spline shafts that you'll see. The one on the top is probably the most common. That's with that blue uh, Teflon-like material on there to keep vibrations and lubrication and stuff. Either one of these is allowed. The one on the bottom is a shaft that's built more for a carrier bearing or something like that to slide onto it. But it's favorable because some people think that it's stronger, it has a better diameter, but the way it's made there at the base where it hooks onto the drive shaft is stronger. So either one of these is allowed. Now the bottom one, obviously, you'll see it has a lot of splines. So don't make a mistake and say, oh, well, the splines are sticking out. Like in this case, you look at that and think, well, the splines are sticking out. Well, yeah, but it's still plenty engaged. So it's just the way that it's made.
Yeah,
So that can trick you.
This is the other style.
In that case, the splines are sticking out too far. You can see here that that's not going to work.
The reason that's an issue is that in the majority of cases, the 4-link bar length is different than the drive shaft length. So as a result, the drive shaft changes in length through the cycle. And in some cases it gets shorter under and droop when the truck's in the air, or it gets longer when as the suspension compresses. It really depends on the geometry of the suspension. So it's important that the drive shaft has the ability to change lengths without either bottoming out or getting pulled apart. And the other critical issue there is in like situations where you have them pulled out very far like that, they'll have a tendency, because there's a bit of a tolerance there between the engagement of the splines. The further out you have them, the more that they tend to oscillate, they'll rock, and that can cause an oscillation and cause the drive shaft to fail. So it's not necessarily just the fact that the drive shaft is going to pull apart. It's creating a situation where you could have a failure strictly because you don't have enough engagement.
And you also showed a picture there with a rubber sleeve.
Yeah.
And that's kind of that's a thing now that Feld requires, and I think some other promoters are starting to require. They want that rubber sleeve on there. It's a piece of hose, and the idea is that if the U-joint failed and the slip yoke net was loose now, it can't slide together too far and get out of the loop and get out of the containment shield. So it still allows that if the drive shaft needs to move, it just smashes the rubber and then comes back, returns back, and so it doesn't hurt anything. But without that yoke can slide together if the U-joint fails, and conceivably get outside the U-joint containment sleeve. So a good idea to have those on there, especially in arenas where everything is close. It is a good idea to have that rubber hose on there. So if you see that, that's what that's.
And you want to make, we've seen cases where that will be, because sometimes guys will put them together and they forgot to put it on. And so what they'll do is they'll cut one and put it on with tie wraps. No, that won't work. It's got to be a solid piece.
Yeah. And also in this picture, you can see a cable restraint on that loop. Again, some places require that. They want those tethered.
I've got that
So
further down on the presentation.
okay. Now the dual braking system. What we're talking about here is we want to see two master cylinders, one for the front and one for the rear. Not a like your production car that has one master cylinder with two chambers in it. These are completely separate master cylinders so that if there's a failure somewhere, a line torn off, whatever the case may be, you still got some braking capability. The whole system hasn't failed. So that's why we want the different front and different rear ones. So um, some people get confused by that. They think, well, this one's got two chambers. No, we want separate ones. One brake pedal controls them, um, but just and that brake pedal, when you look at it, make sure that it's something that a guy can hit. Little tiny brake pedals that come with a lot of pedal assemblies that you buy for race cars. They're figuring that maybe there's a clutch and stuff in there, clutch pedal and stuff in there in a foot box of some little GT car or something. And a guy with size 14 work boots isn't, or big driving shoes isn't trying to push on that thing. Put a pedal in there that you can hit. Um, get you a good target. Because I've seen too many of those where guys use them stock ones that, like I say, they're designed for a little foot box and a little race car where there's a gas pedal and a clutch pedal and a brake pedal in a real small area, and you're switching back and forth and all that. So, not the case to monster truck. You got the gas pedal over here, the brake pedal over here. Put a pedal in that thing. The billet steel rotors. Also very important. In the old days, maybe a rotor off a 3/4 ton truck bolted to the backside of a 5 ton was an okay brake system, but not when trucks are approaching 100 miles an hour and the stuff that they can do nowadays. We got to have a good braking system. Billet rotors. There's some that are funny shaped like these from Brakeman. There's several different manufacturers that people use. In this case, we've got shielding on there because it is on the exposed end of it. In this case, it was a 5 ton and it's on the open end of the 5 ton. Most of the time, you're going to find the brakes are on the side with the drive shaft going to it. On a 106 or a ZF or some other kind of racing axle, and so we don't require any kind of a shield to keep the rotor from coming off. But if it's on the back side of a 5 ton like this one is, we do require shielding to keep in case the rotor came apart. It's shielded.
Big area of concern when you're doing your inspections is checking the bolts that hold a rotor to the flange there. You want to make sure that they're using the prevailing torque nuts, that they're not nylocks. Those things get red hot. The brakes get red hot all the time, and the nylon melts right out of them. So, and then they're useless. So they need to be those nuts that look like they're crushed, they're called prevailing torque nuts. They're a pain in the ass to work with. They're hard to get back off once you put them on, but you don't want those things backing off. You notice here, and when you do your inspection, you want to look and make sure all the bolts are there. So, a lot of times it's not neglect. Sometimes these things get hot. That's one of the problems with the brake system is that they generate so much heat that even using grade 8 bolts and everything, that getting those things red hot like that, they lose their temper right quick. So there's something that they need to be watched quite often. They need to be checked every weekly or nightly. If it's multiple performances over the weekend, you want to just quickly look. I mean, it takes 5 seconds to just look, make sure everything's there. There are rotors, and I don't think I put that in this, but I recently noticed that a couple of trucks had rotors that were threaded, that didn't have nuts. that the bolts just screw straight into the rotor itself, I wouldn't trust that. I think that it's important that just like the throttle linkage thing. I think it's important that we go all the way through that and nut it, because there is no way to have any sort of, like a resistance like that. In other words, if it's designed to be threaded, you're going to use Loctite, it's going to be useless. It needs to have a lock nut of some sort. It's something that I don't believe we've revised the rule about that yet, but as inspectors, you've got to ensure it's not worded in that way only because we had not seen rotors that were threaded like that. We will update that rule to ensure that all bolts must have, and I think they do say that they must have prevailing torque nuts, but it's like not taking into account that some don't have nuts. So we want to make sure that always the rotors have nuts on all the bolts.
Yeah, and it is really common for those to be missing. So
Yeah,
look for those, and also the caliper bolts sometimes will come out, and the caliper's just hanging on by one bolt instead of two or something. And you can look at the pads.
There you go. I didn't realize I had put that in. You see that the rotor is actually threaded. The bolts are screwing into the rotor. It needs longer bolts with nuts on the backside of that.
Yeah, look at the pads. Make sure that they're not worn down too far, and that the pistons are sticking out of the caliper too far. Because just the other thing is that we've noticed a lot is that the pads will wear, and up on the top, they don't ride down on the rotor exactly, perfectly. They stick up off the top a little bit, and they'll wear, and then they'll touch. And then the brake will essentially is worthless because the pads will smash together, but they're not cramping down on the rotor enough. So be aware of that. Look at those pads. Take a good look at those pads and make sure that there's not too much caliper or too much piston sticking out of the caliper, like it's about to fail. Make sure all the bolts are there. Make sure that those pads aren't touching at the top. Look at those vent holes. Some rotors are drilled with vent holes like that. Though that's a common cracking point. Those rotors can start to crack in those holes, and then they're not far from failure behind after that. So pay a lot of attention when you're looking at the brakes, especially these trucks running in arenas. Walls come up fast, and we don't need I mean, obviously that creates problems on every level: building damage, truck damage.
What happens when you lose a bolt on one of these, the as the caliper clamps a spot, and if it's missing a bolt, what will happen is that the rotor wants to pull away, and it'll actually peel the rotor right out. It comes out in a strip. You'll see it. It's actually not all that uncommon failure. You'll see that something that looks like a glowing piece of flat stock out on the track, and what that was a rotor that just went through the caliper and was straightened out and gets spit out. So you definitely need to make sure that all the bolts and all the hardware are there.
And we're going to move to inside the cab inspection now. Climb up in the cab, look for the RII transmitter, or excuse me, the receiver. We want to, there's probably one of the most common kind you're going to see. Check the lights, make sure it works, left and right, center, the lane lights work. Here's a different type of system that I think is in development, so they're still working on it. There's a few systems that have come and gone over the years, but this is one that is resettable and has a whole bunch of different options that once it gets out there, it's going to be pretty revolutionary. The lights up there in the, everybody's familiar with them, I think, the yellow on the left and the red on the right. Indicating to the track officials that the RII system's on and doing its job. The RII antenna. Some RII units had them. Birch supplies them with his radios. It tells you not to use them unless you absolutely have to have them. He'd prefer you not use them. But when it is required, like on this Audiax unit that this one is, they want the antenna straight up and down. Something about called a cone of silence or something, the way that radio waves travel. They want that antenna straight up and down. So if it is an older unit that's has an antenna straight up and down, not sticking straight out.
Some promoters, they require that if the radio or the receiver has provisions for an antenna, that you must have an antenna on it. But if it doesn't have provisions, then you obviously don't have to have it. But that we've seen it, we've had issues with that in the past.
The backup alarm, mechanically activated. So when the truck goes into reverse, it automatically comes on. Not the driver turns it on or something. It just automatically comes on. Commercial unit, pretty common. The backup light, we want a light on there so that it also attracts attention. There was an accident, earlier this year with the truck backing up. So really important. Backup cameras are just around the corner now. Feld's requiring them. So that's something that we'll talk about. There's so much of that stuff has become cheaply available, and it's kind of like an additional insurance policy. But it just helps. But we want that.
The lights are important because, very often, like in the situation that we saw recently, when multiple trucks are running on the floor, sometimes you can't tell which is the one that's backing up. If you can't hear the backup alarm over all the engines running, at least okay, that truck is in reverse. The light will catch your attention. It's more important than what people give it credit to it.
Yep. The in-cab kill switch shuts off all the battery power. Push it to shut it off. All the switches are labeled. We want them labeled.
It's very important that be a push to kill. We have seen situations where trucks have twist type in the cab. That won't work. The idea of the push kill is that in an emergency, throttle hangs or something, the driver needs to be able to quickly hit that button, not have to grab for something or turn something. In other words, it needs to be to where he can do it with his eyes closed. He can just smack that thing. It's one of those things you hope you never have to use in an emergency situation. But I think we've all experienced points at one time or another where we had to use it. Bob, did you have a question?
No.
Okay.
He's got that cool arrow going there. That's pretty neat technology. Leave it to somebody like him to come up with that. All right, so we're clear on that. We want to push to kill. In-cab fuel shut off. Mark it so that you know which direction it goes, whether it's pull off or push off.
Yeah, that one's doesn't have to be a push to on, or in other words, that one can operate in either direction as long as it's marked.
Yeah, we just want it marked. The fire suppression system. With the nozzles that come with it, use the nozzles that come with it. A small bottle, the feeding too many nozzles doesn't work. The guy may have good intentions. I'll put some extra nozzles in this baby, put some out here, put some over here, well, then the system doesn't work correctly. It's designed to work only with what comes with it in the box, which usually is 2 of those nozzles. That's a 3 nozzle head, but that counts as 1. And 2 of those is what the typical system will fire. The extinguisher. pay attention to how it's mounted. There's some really trick mounts out there now. There's all kinds of options for mounting a fire extinguisher in a race car. If you're going to have one in there so that it doesn't come loose, other than duct taping it or rendering it essentially useless to the frame, there's so many trick mounts that you can quickly get at it if you need it. And it's got a tag on it to prove that it's up to date. And
Yeah,
a lot of like car crushes or events like that, maybe there's no other fire extinguishers around. Hopefully in the arena at the show that we're doing here today in the arena, we've got plenty of fire extinguishers and trained personnel to run them and all of that stuff. But maybe we're somewhere where we're the only guy there, single truck exhibition, whatever. That's kind of where this came about.
and for your, for the promoters, for your own protection, make sure that those things are up to date, that the inspection tags are current. We've run into situations where the fire marshal came in right before a show and saw that some of the fire extinguishers were out of date and wouldn't let us run. And, on a Saturday afternoon, sometimes it's hard to find somebody that can do the certification or the inspection. So you want to be on top of that. That may not be something that happens too often, but those kind of things always, seem to happen at the most unopportune time. So just be cognizant of that.
The 5-point harness, our seatbelt system, we require a 3-inch lap belt and the 2-inch. It can have a 2-inch shoulder. 16.1 is the spec, the SFI spec. They've switched the tags up recently, and they now say like when they expire, as opposed to when they were last certified. But in any case, we want them within 2 years. So I think the old way of doing it's gone now. So you're going to see only with the expiration date on there. So make sure that they're mounted correctly. Of course, this is this always comes up with how they're mounted, the bolt sizes and all that we specify in the book. There are ratchet ones, there are cam lock ones, there are latch and link ones. There's so many different systems here that drivers prefer. Some drivers want to ratchet themselves in there. Some drivers prefer the old pull down tight. We're 3-inch on the lap belt, but we do allow the 2-inch section that fits better over the Hans. All the seatbelt manufacturers, almost every sanctioning body now requires some kind of head and neck restraint system. So they manufacture the seatbelts so that they fit to those head and neck restraint systems. So
you want to watch for this when you do your inspection. Make sure that the belts are pulled straight. You see how that is kinked there? That creates a stress riser in the strap, and it can actually be a tear point. It's very important. It seems like something minor, but it's very important that the angle is straight in line with the belt. There's a term for that. I can't remember what the term is right off the top of my head. Where the shoulder straps attach is very critical. The rule book has an extensive explanation of the proper mounting and the way that the belt is supposed to loop through and everything, but the shoulder straps need to mount below the shoulder height, not above, because then if they angle up, then they're not gonna hold the driver in properly. So you notice there that the mounting tabs are below the actual point where it passes through the seat.
no fuel.
I highly encourage you to review that section of the rule book and familiarize yourself with all the little intricacies of how the belts are supposed to function, because again, that's one of those areas that you can have all the right components, but have them configured in a way that they're not going to function properly.
Okay, we don't want any fuel, batteries, radiators, water hoses in the driver's compartment. So any hydraulic lines that are passing through need to be shielded. Look out for those cheap plastic oil pressure gauges, hoses like this one that come, with the gauge kit. Those aren't. I mean, that's just not, has no place on a race car. So we don't allow those things. So make sure that that oil pressure line in the cab is a good hydraulic line type line, or some kind of braided line or whatever, something that's pretty good. And then obviously no other, none of those other combustibles in the cab. The starter interrupt and reverse gear. This is another thing that is guys are starting to modify some of these things to do two-wheel stunts and stuff so they can switch between reverse and forward gears real easy. There has to be a reverse gear lockout. I know one sanctioning body, if they catch you modifying their shifter, they caught some of their own guys doing that, and they said no. So just don't watch for that, because people will file reverse lockout gates out of the way or stubs off or something that to make it so that they can quickly switch from reverse to forward gears so they can do some of these new stunts and stuff. Well, the stunts are impressive and cool, but we don't allow that. Obviously, transmissions don't need any help exploding. We already can do that quite well, so we don't need any to further help them by shoving them between reverse and forward gears.
Yeah,
So
what Tim's referring to is those little detents that you see there, the gates. They'll file those down so they can go back and forth between the gears easier.
So we want that. All right, now a toe strap. This is a real common gas pedal, probably one of the most common kinds, but there are others. There's that toe strap, so that if it does stick down along with that push-pull cable that we talked about earlier, the driver can pull back up. Make sure it's robust enough that when you pull back up, it's going to, obviously you're dealing with a stuck throttle if you need that. So you want to pull back up. It's not just going to bend. So we want it to come back up. So a pretty robust, and it can be open to either side. All right, and here's some miscellaneous safety items.
This gets to the area of greatest concern. Again, like I mentioned earlier about the interface between the wheel and the truck itself, the axles and everything. In other words, we've got several failure points there that need to be inspected periodically. I would say as often as possible. And some of these things you're going to need to do as you're walking through the pit area, a lot of times before the trucks are tired up. Right off the bat, you want to make sure that they always have all the lug nuts in place. Related to that, the interface between the lug nut and the wheel is critical. This is really subtle, but it's important to recognize the potential. If you notice the taper on that, how far in that is into the wheel, you notice how it's actually below the surface of the wheel. You've got to keep in mind the amount of surface area that those, see, let me back up a touch. With Clark Clark hubs with a lot of these beadlock wheels, the reduced diameter barrel of the wheel does not lend itself to a conventional lug nut. They have a hard time getting a socket on there, or the socket will rub the wheel, so they choose not to. So they run inner bud nuts like this, so they can use a square taper to get those things on. The problem is that those studs only have a very, very small surface area. So just picture in that last example that you saw, if that surface of that lug nut is countersunk already, that wheel is grabbing, less than 1/8 of an inch of material there. That taper, you see how thin the wheel gets when you start tapering that in? That other wheel was tapered further than this one. So that inner material is really thin. And we have seen so many failures lately where the wheels will pull right through the lug nuts. So that's one of those things that it's not a rule, because it's really hard to write a rule that covers so many different ways of messing it up. It's one of those things that you just have to be observant. You need to look for that. Make sure that it looks right to you, that it doesn't look like a concern. What some guys are doing now as a fail-safe is they are going in, if they're using these inner bud nuts, after the wheel is mounted, they'll go back and, let's say, put 4 or 5 regular conventional lug nuts on there, even if they're not, torqued way down, but at least they'll capture the wheel. If the wheel was to pull through, it'll only move so far, because a conventional nut has a lot more surface area. It won't pull through that. So that's one area to watch. Beyond that, the next one in is that's kind of distorted, is the wheel stud itself. From tiring up these trucks week after week, day after day, sometimes multiple times a week, crews that are not, or they're in a hurry or anything, they have a tendency of loosening all the lug nuts and just dropping the truck. Those wheels are hammering on those threads time after time after time. And you see how they're beat down? The threads, little by little, those things are capturing less and less thread, or they have less and less thread engagement. And eventually what happens is the threads strip. We're seeing this more and more often now. And this is an issue we've been trying to come up with an adequate solution for. There are gauges you can get at a lot of truck stops offer these little plastic gauges that you can use to check the threads. Because I believe DOT actually checks that periodically on over the road trucks. So there are these gauges available, but you as inspectors, as you're walking through the pits, as trucks are tiring up or anything, just be observant. Go and, look, try to make it a point to check every truck, even if you don't get them all in one day, just keep, because, this isn't something you necessarily have to check every week, but just keep in mind, all right, I checked that truck already. Let me check the ones on this truck, and just go through there and check their studs, also the lug nuts. Tim's mentioned that a lot of the lug nuts you get like at truck stops and stuff nowadays, they're like made in China. Like we've noticed that the quality of them is not what it once was, and they seem to be more prone to getting stripped. Sometimes just putting them on with an impact wrench, you'll strip them. That they're just not.
And you think about these things, on a over the road truck, the tires and wheels come off, maybe 100 times in its whole life, and we'll do that in the summertime, and when you'll do that much more often, you're taking the wheels on and off, and like Marty said, you're dragging them across there. And it's just, we're so hard on these, and the quality isn't what it once was. Even brand name ones are not as good as what they once were. And I don't know if they're using cheaper alloys or different machining techniques or whatever to make them cheaper, faster, whatever. But boy,
Euclids, I guess, are the kind of mainstay.
I think that's the kind of the top of the line, of the industry. But I tried some different ones here, here recently, and they didn't. I thought maybe they would work good too from another well-known American brand, but they didn't. They just didn't. So disappointed. Went back to the Euclid ones, but really, really common failure, and the wheel restraint that doesn't help us in that situation. So super
Yeah.
critical. Guys tire up and get bullshitting or something and don't, they don't finish putting the wheel on, or maybe they only put 5 on to tighten it because they used the 5 that they were on the transport tire, and they put those on, and then they got to go get the lug nut box and bring the lug nuts over and put the rest of them on. Well, they forgot to do that. They had a sandwich or something and sat down and didn't put the rest of them on. If you're an inspector, just it doesn't hurt to poke your head in the wheel and make sure they're all in there.
Yeah, and the one thing that there's really no good way to police it, but just for your own information. One of the reasons that we see these kind of issues, because this is like probably the area of greatest concern, because it's the one that I would say potentially affects or could have an impact on spectators, is losing wheels. So this is, anything that gets away from the truck is a big concern to us. Like there's a different level of concern for competitors, the competitor safety versus the spectator safety comes first. So the issue is that sometimes when you have crews that are not seasoned, they will not follow proper procedure in mounting the wheels. They won't take the time because they get in a hurry, and they won't take the time to get the wheel perfectly centered before they tighten the lug nuts. Sometimes they'll tighten them. They're tight, but they're not centered. So as soon as the truck moves, the wheel moves just a little bit. Now it's loose. In other words, you've got the hole that the wheel stud is in. If it's off center, the wheel will because these wheels use a taper. They'll tighten up against one side of the hole, not the full diameter or circumference of the hole. So it's very important that they take their time to get the wheel properly centered. And then that's why the good seasoned techs, after they're tired up and the truck moves from the pit area to the floor, they will go back and recheck the lug nuts just in case the wheel wasn't perfectly centered and it moved and now it's loose. They'll go back because they'll kind of center up for a minute until you go out and run hard, right? So moving the truck, once the truck is in its parking spot, going back over the lug nuts one more time is a really good, good best practice to make sure that is not an issue. It's no guarantee because, again, you have multiple layers of potential failure, but at least you're eliminating that one, as eliminating one of the variables. And what happens, because this is kind of like tends to be this domino effect. When lug nuts get loose, let's say they don't strip, they just get loose. That movement will load the flange on a Clark. A Clark has an inherent flaw. And that's why CRD makes aftermarket hubs for them that are really expensive, but it's because of this failure point. And there are also girdles that some teams will use to support this flange, because the flange, well, to finish my thought there, when the lug nuts get loose, the wheel can move. It works against that flange, and that flange has a stress riser, has a weak spot in it that will allow that to snap, and the whole ring will break off, as you see in that picture. And there goes the wheel. Wheel restraint won't stop that. And we see that failure right there very often, too often. And there's really nothing we can, there's no conceivable way of capturing that. We have the only way to keep this from happening is maintenance, making sure that these things are not allowed to happen. The steps that before this happens. And here you see where that weakness, you see how thin that gets right there. You've got this really heavy wheel tire assembly and hub assembly. You got the planet gears and everything. You got this, and then it's held on by this really thin piece that whenever you have a corner, that's a failure point. Usually things tend to be tapered, for whatever reason. You're talking about this is like a 1950s design. The original Clark hubs are a pretty old design. So that's why the newer version, the reproductions, the Clark, the CRD hubs, the material is thicker or the tapers are different, and they actually have webbing on the backside to keep those from failing. But short of that, you will see, oh, I don't have it in here. There are teams that run a girdle. There's a plate that goes on the back side of that won't allow that to happen. It's a support plate that attaches to the back side of the wheel stud that'll keep that from being able to flex and break off.
Yeah, there was a picture of the girdle way back on the restraints. I don't know that you want to go that far back to find it, but there was one on there.
Yeah, I don't want to lose our flow here, but yeah,
Yeah.
just, you know, if anybody has any questions, just, I can send you a picture of it or anything. It's pretty easy to identify. It's a flat plate and you'll see the bolts that attach to it. They'll very often they will pick up the brake boss, the threads that the brake drums attached to on the Clark hub, and then they'll pick up the wheel studs also. And it's just like a girdle. Very often they'll integrate the rotor for the wheel restraint system right into that. So it's a really good way to keep those Clarks running without having failures or without having to buy the, $2,000 hubs.
Something else, I kind of hate to mention it, but I don't. As you're walking around the pits and guys are tiring up, I've noticed lately with all the bigger impacts that are being made, some guys just really hammer the dog shit out of their studs when they're putting them on, and you can over torque them and stretch the threads and just ruin them by that alone. Also,
yeah, it's unfortunate that, we all, a lot of teams tend to rely on sometimes on guys that are not well seasoned. They're either new or you needed help for a week, weekend, or your normal crew guys out or for whatever reason. And it's really, some of these things are really critical. They seem like, well, it's just putting on tires. It shouldn't be that big of a deal. Like, no, there's a proper procedure for doing this. And if that procedure is not followed, it can create downstream problems. And you don't, the type of problems you don't want to see occur in the middle of a show. It hurts show flow. It's, potential danger. It could do building damage, all these different things. So these are the type of things that are best caught in the pits before the show, on a Friday, but if you've got for a Saturday show or anything, this is just routine things that you need to be observant about. If you, a lot of you inspectors that are on tours that you're used to seeing these trucks week after week. If you see that there's a new guy that you don't recognize, or, hey, that guy, I haven't seen him working with this team, you might want to pay a little bit extra attention to him and make sure that he knows what he's doing and that it's not some fill-in guy that, may not do a good job. And I've seen trucks lose wheels for that exact thing. They had a fill-in tech for a weekend, and they end up costing them some damage, body, fiberglass damage. In the case that I'm thinking of, didn't hurt anything in terms of building or anything, but still don't want to see a truck out there on the floor without a wheel because lug nuts fell off. Now we're going to get into a really sensitive area that we've been harping on for quite some time. And that's tires. This is a big one that it's a increasing concern as these tires have been around since approximately 1967. More of them are out there, more and more. We're starting to see, there seems to be this cottage industry out there of guys selling used tires, where we have no idea what those things came from, what they came off of, what the condition was, why they were taken out of service, all these different things. And then they sit out in fields and dry rot. And they're just a problem waiting to happen. Scott can speak to this issue more than anyone else here. This is something that we have a tentative solution for, at least I wouldn't say it's necessarily a solution, but it's at least to minimize to the best of our ability at this point, this issue of, because what happens when you have tires that get dry rot like this is that moisture works its way down through the rubber. In other words, it's not always that, the sidewall is going to blow out. That's not likely to happen with a truck sitting. But what can happen is that the moisture works its way down to the bead, and inside there, these are metal beads that rust. And when that bead rusts, it breaks through, that tire blows off the rim and it's catastrophic. We've heard this happens way more often than even was recognized. We didn't know this until we started doing some investigation. We hear, oh yeah, this so-and-so had this issue. And these things were happening. And they just weren't really they were kind of under the radar and weren't being recognized. You know, we've heard of instances of tires just blowing right before pit party. You know, and the last thing we want is, you know, a kid standing next to a truck and a tire blows or something. Just, it's unnecessary. You know, we have $250,000 pieces of equipment and you have guys wanting to buy $300 tires. It's just nonsensical. There's just no reason for it. But the stopgap solution, and we mulled over this for years now, a couple of years now, maybe 3 years now, trying to figure out, like, how do we define this? How do we identify which are the tires of concern, which are the ones that are not a concern? We think that, you know, mandating monster truck specific tires might be a step too far. It's too radical of a jump. We don't want to be spending other people's money, but at the same time, we recognize that this is a potential issue. And what Scott came up with through his research, he found that tires produced before the year 2000 had a 3-digit date code on it. Tires produced in the year 2000 had to change to a 4-digit code. So if you see a tire that has a 4-digit code, at least you know that it's no more than 24 years old. If it's got a 3-digit code, it could be as old as 1967. So as an initial step, we suggest not allowing tires with 3-digit codes. You know, and this is obviously at the discretion of the promoters at this point. We have not implemented this as a rule, but it's a very strongly suggested policy. So familiarize yourself, as in tech inspectors, familiarize yourself with these tags that are embossed into the tires and pay attention to that. And look at the condition of the tires also. You know, look at the interface between the rim and the bead of the tire. And if you see any irregularity, that could be an indication that that the wheel or that the tire has a bad bead. And those things are just sitting there waiting to rupture. So, anyone want to add anything to that?
Yeah. And there's also, you know, watching people inflate a tire and walk away. It obviously takes a long time to put some air in the tire. There's been instances of guys hooking up a air compressor and walking away or getting distracted and tires exploding from that. Inspector, if you're walking through the pits, there should never be an air hose connected to a tire that there isn't somebody monitoring it nearby. I've walked through and seen that and asked questions of who's watching it. Oh, I got it. You know, and you're over here on their phone or something. And no, stand here and monitor this or disconnect the hose.
Yeah, that's a good point. This is sort of another unwritten rule that you as a tech inspector should probably be conscious of, is people that are not necessarily paying attention to their job, or people that are in the pit area on their phone, let's say, that are not necessarily paying attention to what's going on around them. It could be in the, you know, as Tim suggests, they're airing up a tire and they're on the phone. You don't know that they're going to get distracted. They get into an argument or something and they forget. They step away. This has happened multiple times. Step away and the tire explodes. And you know, it could be a situation where somebody's not paying attention because they're deeply in some discussion and step into the wrong area. In other words, whenever somebody is in the pit area, that is a danger zone. They need to be paying attention to what they're doing. And you want to make sure, like, if you see them that you sense that they're not totally paying attention, you might go and nudge them. Hey, you know, let's let's be serious here. There's plenty of time to joke around or be on the phone or anything. And you know, it's like you're their boss and you're like, this, you're at work now. You do that on your on your personal time. Pay attention. Don't endanger yourself. Don't endanger those around you. You know, you're at my event. I'm responsible for you, and I don't want to see you get hurt. So just, you know, keep that in mind. There's a lot of little things like that that we never really thought about in the past. But as we've addressed all these other failures and things, now we're getting into these finer details of issues that how can we improve these things? And we're almost done with this, and we'll get into a little bit more of that in just a second. Let's finish through our little presentation here. We'll touch on some other things. This is another one that no one ever thought about, but it has become an issue now because we are doing so much more with the trucks. You're doing these, you know, stoppies and different things. Transmission overflow lines. You know, we used to just let them hang and they'd, you know, dump transmission fluid on the ground periodically. And, you know, of course, as we become more environmentally conscious, we don't want oil on the concrete and stuff, especially at indoor shows and all. But beyond that, now these things are starting to become fire hazards. We don't want trucks doing these type of, you know, performances. Very often, you know, in this transition period, we saw trucks getting upside down, and all, you know, I can say I've done it. You get a truck that's upside down, you flip it back on the tires, and you know, either you're the crew guy or whatever, crew chief, and you go to jump in the truck and it's raining transmission fluid. You don't even want to get in it because the whole roof got covered with tranny fluid where it was coming out the overflow. These tanks, these overflow tanks now are actually a safety component. There's something that we need to be implementing. I think it's critical. You know, again, as tech inspectors, you don't want unnecessary fluids on the ground, you know, potential slip hazards, and then the fire hazards on top of that and everything. So again, we're getting into these finer details of safety things that we never really considered in the past. Tim mentioned this earlier. You know, trucks are getting upside down. They're getting into obstacles more often than ever before. Having the fuel cells in the safe location is more critical than ever. We want to make sure that they're protected, that they're not exposed. You know, we used to see trucks with fuel cells hanging off the back. We've seen trucks with fuel cells in the driver's compartment. You know, trucks have become far more standardized. There's much less variation between chassis designs and everything, but you want to make sure that their fuel cells are guarded, that they're not overly exposed. We do see them, you know, trucks will get, you know, will wheelie and land on the back. And I'm seeing a message here. Jeremy is saying perhaps we need to be more strict on old tires on ride trucks. Yeah, absolutely. That suggestion on the tires is across the board. In fact, it may actually be more critical on a ride truck because there are more spectators that tend to be around ride trucks than they are. We've seen on multiple occasions ride trucks lose wheels and this is because more often than not, because people seem to think that, oh, that's a lower priority. That's not a competition truck. Let's just get, you know, weekend help to drive it or help people, you know, get in and out of it or, you know, these type of things. And they're the ones helping tire the truck up. We've had multiple instances of ride trucks losing tires. You know, you'd say, how does that happen? They're just driving around in a circle all day long. Well, you have somebody that doesn't know what they're doing, putting the wheels on, they don't get them centered and you have issues. So yeah, absolutely. These tire recommendations apply to all trucks, period. This is a, you know, one of those dangers just lurking in the corner waiting to bite us. It's not a, you guys that go attend a lot of these meetings have heard me say this 1,000 times and it sound like a broken record, but if it can happen, it eventually will. It's just a matter of time. Restraints on sway bar links, that, you know, the sway bar arms, that is one of those things like, how is that a safety thing? Well, it is when the arms get into the tires. We've seen instances where sway bars break. Anybody who's been around the trucks knows sway bars break. We've seen instances where they come out. Depending on where the break happens, the arms can get loose and the arms can get into the tires and the tires can sling them. So it's, you know, and honestly, it's like you're protecting the owner or the, you know, from himself. That having that keeps you from doing more damage. We've seen instances, many instances where the sway arms will fall and then they hit the hydraulic lines and bust a hydraulic line and you lose steering. There's, you know, multiple different things. They can damage shocks. They can do all this. So having this is a cheap insurance policy. It's just, it's kind of a no-brainer. And Tim mentioned this other, well, this is another level of that at first we were a little reluctant to adopt this, but we've seen them work. These blankets that go over the ends of the drive shafts to capture the smaller parts of the drivetrain. You know, our drive shaft loops and shields and everything do a very good job of containing the big hard parts. But the smaller things like U-joint caps and needle bearings and those type of things, they can sometimes get out because they bounce, right? They can find their way out of these little smaller holes. These blankets actually do a pretty good job of containing all the small parts. Very, you know, often you know, we pull these things off and you'll find all sorts of shrapnel in there that otherwise would have probably found its way away from the truck somewhere. And they can be cumbersome to work with and everything, but they're not a bad idea in this, like if you're going to really focus on trying to keep everything as contained as possible. And then this relates to how the vehicle is run too. If the promoter that you work for allows trucks to run when they're not on all fours, or if they're on their sidewalls, we've seen there's some promoters that allow trucks to mat it when they're on their roofs. In other words, we don't condone that. In fact, we hate seeing it, but it happens. So in situations like that, where the drive lines are exposed to the sky, you know, to the air, they're out in the open like that, what goes up is going to come down. It's good to have this extra bit of insurance. The other thing was the restraints or the cables on the drive shaft loops. That's another good bit of insurance. Sometimes you'll have, because of a driveline failure, you'll have the loops get broke. They stay in one piece, but they'll break the rods or anything. Allow the cables, if they're properly sized, will keep that from allowing the loops to fall all the way to the ground, where they can get hung up on the ground and get ripped out from under. We've had cases where they fall, they catch the ground, and then they're pulled under the rear axle and get spit out the back. So, and when that happens, now the drive shaft gets loose or can escape the loop. So just having that little cable is, you know, again, a little cheap insurance policy. Does anybody have any questions about anything before we wrap up here? We've been at this a little over 2 hours. I can unmute everybody if you don't want to type. If anybody has any questions, just put a Q in the chat and I'll unmute you and you can voice your opinion.
Hello?
Yep, we can hear
me.
you. Yep.
Okay. I've been seeing a lot more and more trucks on our tour running the aluminum, the 7073 aluminum tie rods and 4-link bars. And And while I've had my doubts of them at first, I'm realizing they are extremely strong. But I'm very concerned with the kinetic energy that they have sometimes. And I know some promoters are uh, mandating tethers on them as well. I've one of our shows, we had a truck do a reverser and it had some, he was trying out some new Heim joints. Well, it turns out the Heim joints just got pulled out of the bars. And while some of the tethers did work, some of the straps were pulled out. I took a lot of photos of this, but I just was wondering if there's going to be more of an area of concern for something that is stronger, but does have more of a kinetic energy at a break point that should have a tether on it.
That's a great question. This is an area we have been looking at and discussing for a couple of years now. We've talked about, some of us on the board have talked about running or testing these things. The big issue for us with that, with the aluminum bars is not the strength of the bars themselves. They are, anybody that's run rock crawlers and everything knows aluminum wheels can be stronger than steel wheels because they can deform and go back to shape. So, that's not the concern. It's not the bars themselves. The issue is the interface between the rod end and the threads.
Yep.
The aluminum threads are not particularly strong, so we have toyed around with different ideas. Like ideally, one of the things that we talked about was having these sleeves, steel sleeves that would go into the aluminum that would increase the diameter so you had more thread engagement. And they could actually even work, depending on how you did this, they could actually be an adjuster that would allow you to adjust your, centering of your axle or adjusting your rod end or your 4-link bar length just by turning that interface, because you'd have reverse threads on them and you could actually make adjustments there. So they actually would serve a dual purpose, but they would increase the diameter, which greatly increases the strength of that. But you're absolutely right. And depending on the hardness of the aluminum, because that process is critical as well, you can get them to where they're too hard or too soft, and finding the right spot. We just haven't. We don't have enough time with them. They haven't been out there in our industry long enough to be able to make any sort of determination of what is the right spec, right? So we don't want to see that pulling. But if you have pictures of failures like that or anything of concern, please, by all means, send them to us. We'd love, we have a huge database of broken parts and things, and that's very helpful for us in developing solutions to these things. So thank you for that question. It's a good one.
Yeah, because I noticed some of them too, like the tabs, even though it's like a 1/4-inch steel tab, it's still pulling the strap at such a hard rate. It's still shearing the strap, because it's on 2 points of the metal, where it's pulling it. So yeah, it's like you said, we haven't failed these enough to learn from them yet, So like, yeah, it's going to be like a work in progress. I feel though, like it's almost like the wheel tethers. It took us a while to come up with a better system for that. So it's going to be like a work in progress, I think, kind of thing.
Yeah, one of the that double shear thing there's multiple facets to that. One of the things is, very early on we had people doing shock mounts that were in single shear, 4-link bars, all sorts of things that were in single shear, and by adding that second tab, you vastly improve the strength component. But beyond that, what you end up having is that you have, and we learned this back in the probably early 90s. We started experiencing this where you have wear in the bolt holes. When you had smaller tabs or thinner material, the bolts were hammering into those mounts and you start oblonging the holes. So you needed more surface area. The other thing, and we're starting to get into like more of the technical, truck construction issues, but as we increased the surface area of the tabs to address that issue, you started running into issues where bolts were not properly sized. And this is like in the weeds, but the shoulder of the bolt is critical. You don't want threads in the area of the tab because you're talking about you're hitting the edge of the threads, and you get bolts that start to rock, and then now you're starting to oblong the holes, and you got this again domino effect. So
Right.
it's really critical that the bolts are properly length, proper length. Very often that requires like custom bolts, or everything needs to be engineered to have the proper width spec to the bolts. And but those are, again, these finer details that are a sign that we're doing a pretty good job of identifying the issues with the vehicles themselves. Little by little, the issues are becoming more focused. Like sometimes we were like, the little Dutch boy trying to, stick his finger in the dike, and then you leak here, leak there, and we were chasing so many things that we could only focus on so much. Well, we've been doing this long enough, to our credit, patting ourselves on the back. We have addressed enough of these things for so long that we've gotten this down to almost to a science. We know where our weaknesses are. We know the things that we need to address. And that's a leading statement. More often than not, the issues we're seeing are not so much vehicle related. They're the environment that the trucks are operating in, or in the manner in which they're being operated, not entirely the vehicle itself. We there were a few things that happened this week that I'm sure many of you are aware of, and we were reluctant to comment on any of this stuff on social media because it's pointless. It just leads to arguing. Half the time, the people that are speaking don't even know what they're talking about, or they don't know all the different facets of, it's sometimes things are more complex than they might appear. But bottom line, because I saw this and it took a lot of restraint to keep me from chiming in and saying, look, you guys, you don't understand that we develop rules to protect the masses from the short-sightedness of the few. Then that includes protecting the industry from individuals within the industry. It's very easy to say, well, if somebody chooses to put their life in danger, that's on them. Well, that's not true, because they are endangering the longevity of our industry when they do that. In other words, I'm speaking hypothetically, you may not care about yourself, but we will not allow you to tarnish the image of our industry because of your short-sightedness. We cannot condone or allow people to do things that we know is wrong, right? We need to make sure, and I'm not suggesting that we're all perfect. We're not. We all make mistakes. We've all done things we were, in hindsight, that was not the smartest thing to do, right? But we learn from our mistakes. We don't go backwards, you don't, next time you're driving along and you get pulled over for not wearing your seatbelt, try getting out of the ticket by telling the cop, oh, well, cars in the 60s didn't have seatbelts. No, that's not an excuse. That does not excuse not following the rules of today. We learn from our mistakes. We're doing this to protect the entire industry, not just the individual. So I'm sorry that I'm passionate about this. I get upset when I see people that can't see past the tip of their nose. They can only address the most obvious thing and don't see the big picture of how those things affect everything around it. We have been burdened with this, I believe, somewhat unfair stigma that I think has constrained the monster truck industry from the very beginning. If you recognize the number of spectators, the amount of exposure that the monster truck industry actually has as compared to most motorsports, we should have sponsors knocking down our doors to get on board with us because of the return on their investment. but we don't because we're stigmatized by stupidity of things that look unprofessional that could easily be addressed. If people were to open their eyes and go, look, if you want to be treated as a professional motorsport, you need to act like a professional motorsport. Sorry, I could keep on all night on this, but I'm gonna let other people speak now.
Other
Tim?
questions?
Well,
Alright.
if nobody has any questions, that may be a good thing. Maybe we explained stuff well.
Yeah. Well, again, you can get a copy of the rule book in the download section on the web page. And I encourage the MTRA needs your support. We need at least join at the associate level. Consider joining at the associate level. It's like $40. We need membership. Membership drives this thing. It takes all the people that work with the board. Everybody, nobody's paid. We're volunteers. We're not. We don't need the money for ourselves. We need the money for the organization to continue, so that the organization can produce these things and these books and all of these things and have stuff. And we got to pay our SFI dues every year, and we need membership. Sound like the guy on the PBS TV station there, but we need your support. So at least consider joining at the associate level, if not a higher race team affiliate if you are, or if you work with teams. Have them consider becoming a member. It's not terribly expensive in the overall scheme of things, and every promoter out there uses the rules. The MTRA rules. We got to meet MTRA rules to put it right in their contracts, even though they're not MTRA member promoters. But just think, it's not hard to realize where the sport would be without some kind of guidance. So, consider joining if you would.
I have one more rant. Only because I have to address a comment that I saw that, again, took a lot of restraint to not respond to. But there was a suggestion that very few promoters out there are using MTRA rules. Understand that all the rules out there are MTRA rules, all but the evolutionary people that, one or two promoters that took MTRA rules and then expanded upon them, in an evolutionary process. We are the ones developing the rules. If it wasn't for the foresight of Mr. Bob Chandler sitting here, we wouldn't be here today. We would have the industry would have put itself out of business long ago. You cannot quantify the number of lives that have been saved by all of these things we discussed tonight. It's very easy to minimize them and take them for granted, but somebody had to do it. And in order for us to keep doing it, we need the support of the community, the people that actually care about the industry. It's quite burdensome to be the conscience for an industry that doesn't always care for itself. Like, we're carrying the weight of people that don't even appreciate that we're trying to help them. And, and I'm not trying to pat ourselves on the back or anything. We elected to take this burden on for ourselves. But I think that gives us maybe a little bit of justification for pointing out deficiencies, right? These are the areas we would like to see improved, so that would make these discussions more hypothetical rather than speaking about actual incidents that occurred. So with that said, unless anyone has anything to add, I think we can call it a night, and everybody can get on with their normal lives again.
Thanks,
Marty,
everybody, for joining us.
Marty, it's Bob Bennett real quick. Can you hear me okay?
Yes, Bob.
Hey, Marty and Tim and everyone else, we just, from the Hot Wheels Monster Trucks Live organization, we want to thank you for all of your continued support and your efforts in putting this together. It was greatly appreciated. And then just a note for everyone from within our Hot Wheels organization that's in attendance this evening. If any of you need the inspection sheet or the rule book, please shoot me a text and I'll email that over to you. Again, Marty, Tim, everyone else, thank you so much.
Thanks, Bob.
Thank you. Appreciate you being here.
Thank you.
Unless anyone else has anything to add, I think we can call it a night.
Thanks, everyone. See you
Thank
at the
you.
next one.
Thanks for having me.
Thank you.
Yeah.
Thank you, guys.